Hello, boys and girls. Today we are going to be on page 20 of our Unit 2 packet, and we're going to be solving some ratio problems. Can't wait. Can't wait to do them. We're going to start off on page 20 with this one on top here about whales. So I'll read it to you, and then we'll start it off here. It says, a scientist studied the migration patterns of two types of whales. Now, migration is talking about movement from one place to another. So the humpback whales traveled 2,240 miles in 28 days. The gray whales traveled 2,368 miles in 32 days. It says if the humpback whales had traveled at the same rate for 32 days, how many more miles would they have traveled than the gray whales? So one thing to note here, okay, actually a couple things. One is that the humpback whales, we want the humpback whales to travel for 32 days. They have not traveled for 32 days yet. They've only traveled for 28. The gray whales, however, have traveled for 32 days. So what this problem is asking us to do is compare these two whales after 32 days to see how much farther the gray whale would have traveled. So we're going to leave the gray whale information there on its own because we don't have to change it at all because it's already at 32 days. What we're going to do is we're going to set up a ratio table, though, for the humpback whale. And we're going to make a little ratio table like that. So let's think about the units we're going to put down. So on the labels on top, miles in days. So miles and days. So this would be a rate because these are units of measure. Miles and days. So let's put our original ratio down, our original rate down for the humpback whale, which would be 2,240. And then the days would be 28. And what we're trying to do here is we're trying to get to 32 days to compare it to the gray whale. So we're going to put a 32 down below. And this is where not our final answer will be, but this is the number we're trying to locate, is how far would a humpback whale have gotten in 32 days. So let's think about it. Now, this number is a little tricky to deal with, 2,240. So we're looking at 28 and 32. So is there a number that we can get to from 28 that would help us get to 32? Like, we're almost thinking, like, what's the GCF of these two numbers? What's the greatest number we can divide those by? We could do 2, because if we get from 28 to 2, we can then get from 2 to 32. But I think you can divide these both by 4. So if we get to 4 here in the middle, we can then get to 32. I know I have ink all over my fingers. All right, so let's divide to get to 4. What can we divide 28 by to get to 4? Well, that would be 7. So let's divide by 7 on the top. We get to 4, which will then help us get to 32. And we'll divide 7 here as well. I'll divide by 7. Now, and we've talked about this before, like if we don't know how to or what to divide by to get, or not sure what the answer would be in our head, we can always just do it off to the side. That's what the professionals do, of course. So we'll put 2,240 in the box, and the dividend end we'll divide by 7. So again, if you want to try that on your own ahead of me, go ahead and do it. I'll just pause here for a second, see if you can practice this division here. 7 goes into 2 0 times. 7 goes into 22 3 times. Yeah. 3 times 7 would be 21. Subtract, you get 1. Bring down the 4. Oh, this one's not going to be too bad. You bring the 4 down. 7 goes into 14 twice. 2 times 7 is 14. Now we're not done here because we still have a 0. So you got to bring the 0 down. 7 goes into 0 0 times. 0 times 7 is 0. 0 minus 0 is 0. So we have 320 miles in 4 days, which is quite extreme. That's a lot of miles. So now what we're going to do is to get this number here, we're going to have to multiply to get from 4 to 32. And what we'll multiply by would be 8. So we'll do times 8 on the bottom, times 8 on the top. So again, if you can't do 320 in your head, not a problem. we'll do it off to the side. So 320 times 8. Again, I'll give you a pause so you can set that one up. Try that one on your own. Okay. All right, 8 times 0 is 8. 2 times 8 is 16. 6 carry the 1. 8 times 3 is 24. Plus 1 is 25. So it's be 2,560. All right, so in 32 days, the humpback whale traveled 2,560 miles. Now, we're not done yet because we're trying to compare that to the gray whale. So the gray whale in 32 days traveled 2,368 miles. So to find the difference between the two, I'm going to do that down here, I think. We're going to subtract those two numbers. So again, these are steps that you could do ahead of me. So do 2,560 minus 2,368. So we're going to find the difference between the two, see how much farther the humpback whale would have traveled in 32 days. 8 minus 0 would be negative. We have to regroup here. That's going to be a 5. Carry the 1. 10 minus 8 is 2. Okay, we're going to regroup here. 5 would become a 4. That 5 would become a 15. 15 minus 6 is 9. And 4 minus 3 is 1. So that means that the humpback whale would have traveled 192 more miles in 32 days, which would be our answer. Okay, so I'm just going to abbreviate that answer slightly, but humpback whale would travel 192 more miles in 32 days. So that was quite a problem to start off with, but I just wanted to just show you something like this because although the numbers seem like they're pretty complex, the idea behind it is something we've worked on before. Trying to get from one number to the next. Of course, long division, multiplication, subtraction, it's kind of all in here, so I did want to start off with a nice little problem there. That's probably the hardest problem we'll do today, so that's kind of nice. All right, so let's check out the one below it. So we're going to be using ratio tables here. And again, at any point you want to try it on your own, I might say like you can pause the video here, try it, and then see what I got. But the more you can do on your own, the better, because the more practice you get doing it individually, the better you'll get at the skill here. So let's check out number one. We're going to use ratio tables here. Heritage Middle School has 150 students. 2 out of 3 students in Mrs. Mason's class prefer gel toothpaste. There's the ratio right there, 2 out of 3. Use this ratio to predict how many students in the entire middle school prefer gel toothpaste. Now, this middle school is rather small because there's only 150 students, but some different districts, different schools have different amounts of students, I guess. All right, so we'll start with, I know it says bar model and equivalent rates. You can just cross those off. We're going to be using a good old-fashioned ratio table. Okay. All right, so the hard part, the tricky part here is the label. Okay. So the number is 2 out of 3. That's the ratio they give us. So what does the 2 and the 3 refer to? The 2 students are the people that would prefer gel toothpaste out of 3. So 2 prefer gel toothpaste out of 3 total people. So this one's a little hard to decipher, but the label on top would be the gel toothpaste people. And the number on the bottom would just be total. Okay. So we have gel people, we have total people. Just going to zoom in on this there we go, just to get a better view of the ratio table. All right, so the ratio they give us, again, is 2 out of 3. So 2 people prefer gel out of 3 total people. And what we're trying to do is predict how many people in the entire school would prefer gel. So this number here, they give us another number here, 150. What would 150 be? Is that the gel people or is that the total? Well, that's the entire school. It says Heritage Middle School has 150 students. So we're going to put that 150 in the total. And we're trying to get this number here, which is how many people at the school would prefer gel. So I'm going to put a big circle here to signify that that's the number we're trying to get. Now, a question you always want to ask is like, can we get right from 3 to 150? Because if you can, you might as well just do it in one step. And I believe you can. So what we'll do is we'll multiply to get from 3 to 150. Now, to do this, I'm thinking, how can I get from 3 to 15? It'd be times 5, right? So what times 3 would be 150? It would be times 50. Because if times 5 gets us to 15, times 50 would get us to 150. So we do the same thing on the top. 2 times 50. Well, 2 50s would be 100. So that would mean, what does that number mean? That 100 means that, we'll say, it says predict. So we'll say about, this will be our prediction, about 100 students would prefer gel toothpaste. So the reason I'm saying about, again, is it's asking us to make a prediction. It seems like they perhaps only asked Mrs. Mason's class, and so that was just one class out of a whole school. So using this ratio table, however, we can make a prediction about the whole school based on the information we have so far. All right, let's try another one. Let's try a couple more here. Okie dokes. So we have this one here about text messages. All right, it says the ratio of the number of text messages sent by Lucas to the number of text messages sent by his sister is 3 to 4. Lucas sent 18 texts. How many text messages did his sister send? So the labels are really important here. It's really important that we understand what number goes where, but we're going to start out, once again, with a lovely little ratio table. 1, 2, 3. So the next step is we have to know our labels. What are our labels for this particular problem? It says the ratio of the number of text messages sent by Lucas to the number of text messages sent by his sister is 3 to 4. So there's our ratio there. It's important to know, like, what's the ratio they give us? It's 3 to 4. So that looks to be text messages sent by Lucas. So it's Lucas to the number of text messages sent by his sister. All right, so we're going to put Lucas on the top. These are Lucas texts. And then we'll put sis on the bottom. Okay, so the original ratio they give us is 3 to 4. So I'm going to put that in there. And again, if you want to pause and try this on your own and finish the rest of the problem by yourself, that's fine. It says Lucas sent 18 texts. Well, where would we put the 18? The 18 would go on the Lucas on top, on the Lucas row here, so it'd be 18. We're going to leave a little space just in case. And then the sister, we're going to put a big circle because we don't know yet. But again, what you want to look for now is, can I do this in one step? Can I get from 3 to 18 in one step? And it looks like we can. So let's do it. So we're going to go 3 to 18, doing times 6. Same thing on the bottom. 4 times 6 would be 24. So we can say sister sent 24 texts. So again, those two are pretty straightforward because we didn't have to take 2 steps. We didn't have to scale down, then scale up, or scale up and then scale down. We just went right to the number. So let's see what number 4 brings. Perhaps it's something a little bit more complex. It says, Jeremy drove his motorcycle 120 miles in 3 hours. At this rate, how many miles can he drive in 5 hours? At what rate did he drive his motorcycle? So what we'll do is first, we're going to draw a little ratio table. There it is. Now we'll think about what are our labels, what are our units here. We have Jeremy drove his motorcycle 120 miles in 3 hours. So we're going to put miles on top, hours at the bottom. Okay. What's the ratio or the rate they give us right off the bat? Jeremy drove his motorcycle 120 miles in 3 hours. So we'll put that ratio in there to start. So it's 120 miles, 3 hours. It says at this rate, there's two questions here. It says at this rate, how many miles can he drive in 5 hours? At what rate did he drive his motorcycle? Those are two different questions. So the 5 hour one, we're trying to get to 5 hours. So we're trying to go from 3 to 5. We'll do that first. We'll do 5 here. And then we'll put a big circle. All right, so we're thinking, how do we get from 3 to 5? Well, can we simplify 120 and 3? What is the GCF? What is the greatest number we can divide those both by? And I'm looking at these, and I'm thinking that 3 can go into both of them, because 3 can go into 12, so 3 can go into 120. So what we'll do is we'll divide the top and bottom by 3. Divide by 3 on the top, divide by 3 on the bottom. And what's nice is we're going to get to 1 here, and then we can go from 1 to 5 really easily. So 3 divided by 3 is 1. 120 divided by 3, well, 12 divided by 3 is 4. So 120 divided by 3 would be 40. So now we can get to our missing number here by multiplying by 5. So times 5, times 5. 1 times 5 is 5. 4 times 5 is 20. So 40 times 5 would be 200. Now, they've asked us two questions here. So it says at this rate, how many miles can he drive in 5 hours? We'll say 200 miles, abbreviate that, in 5 hours. So that's our answer to the first question. However, they're also asking this question. At what rate did he drive his motorcycle? And I'm actually going to change one of the words here. Instead of rate, we can use the word speed. Like, how fast was he going? How fast was he going? And normally, the speed is reported as the unit rate, or how many per 1 hour. And luckily for us, we already have the unit rate. If you look at our ratio table, that middle rate here tells us the speed. He's going 40 miles per hour. So if he travels for 3 hours, he travels for 5 hours, it looks like he's going at that constant rate. He's not slowing up or speeding down, which would be very difficult to do, but he did it. His rate or speed, his speed is 40 miles per hour, or mph. He's going 40 miles per hour there. All right. So the last thing we're going to do here, I'm going to help you set up the first problem, but you're going to try these two at the bottom here on your own, based on, it's based on what we just practiced together. But I'm going to help you set up this first one, and then you can do the last one on your own. But for both of them, I'm just going to do this real quick. I'm just going to write a ratio table for both, because I know that's what we're going to be using here. All right, so I'm just going to help you with the labels with this first one, and perhaps the first ratio here to help you set this one up. It says, if 1 out of 12 students at a school share a locker, how many share a locker in a school of 456 students? So this is kind of similar to the one we did previously about Heritage Middle School and the gel toothpaste. So we got to think, what are the labels here? If 1 out of 12 students at a school share a locker, how many share a locker in a school of 456 students? So what might be easier here, actually, and this is why this one's a little tricky, is to start off with the ratio. The ratio they give us is 1 out of 12. That's the ratio we're starting off with. So I'm going to put that in here, 1 out of 12. So then, well, what does the 1 mean? What does the 12 mean? If 1 out of students at a school share a locker, 1 out of 12 students share a locker. So these are the share people. 1 person shares a locker out of 12. 12 would be the totals. This is kind of like the gel toothpaste. So it says, how many share a locker in a school of 456 students? So where would the 456 go? Is the 456 the number that share the locker, or is that the total number of students? So 456 would be the total, because we're trying to find how many share a locker. So 456 Now I'm going to give you one last tip here. It's going to be tough to figure out how to go from 12 to 456. You can do it in one step. To figure out what to multiply, here's a pro tip. What you do is this. Off to the side, you do 456 divided by 12. When you get the answer, that will tell you what you need to multiply by. After you finish this one, I want you to try the one right next to it on your own. That one's a little bit more straightforward. But if you have any questions, please let me know. Send me a message on Google Classroom. If not, have a great day, and I'll see you soon. Bye-bye.